Okay, Unit 2, Day 5b. We're going to look at more complex numbers in the fundamental theorem of algebra. Today we're going to do a few different things, but for our little warm-up here, just a quick little warm-up, see if we know what we're doing. Write an equation with this given information. So there's an equation, there's a polynomial. We want to do the lowest degree possible, so we don't want any higher powers than we have to go here. So x equals 1 and negative 2. So it has two roots, which means it's going to be a quadratic. And there's also this information that when I plug in 3, I get 8. Okay, so right off the bat, you may be thinking, okay, well, if it has a factor, if it has roots of 1 and negative 2, then that means factors would be x minus 1 and x plus 2. And that is a good start, because this is an equation. The equation I just wrote is an equation that has those two numbers as zeros. The problem is, if I plug in 3, do I get 8? So over here, does 8 equal 3 minus 1 times 3 plus 2? So this would be 2 times 5. 2 times 5 equal 8. And that's not true. So the problem here is there must be some a. There's some a in here, some value of a that's going to make this, it's either going to vertically stretch it or vertically shrink it so that it goes through this point. Because this one that we had without that, without the a, or if the a was 1, it does not go through that point. So what I'm going to do, we'll say plus 2. Now let's plug it in. So I'm going to plug in 8 for y. That equals 3 minus 1 times 3 plus 2. And this is 2 times 5, so it would be a would equal 10, or a times 10 equals 8. So if I divide both sides by 10, that means a must equal 4/5. So y equals 4/5 x minus 1 and x plus 2. Okay, so that is the one. That's the guy we want. So there's a factored form. You can multiply it out and everything and put it in standard form. That's up to you. It doesn't really say what form to put it in. So I trust that you know how to convert this into standard form. This guy here, the zeros are negative 2 and 3i. So that means we can start out with y equals x minus negative 2, which would be plus 2, and then x minus 3i. Now, if you remember from yesterday, though, we can't stop there because there was this theorem that said that if a plus bi is a 0, then a minus bi is a 0. Well, this is the same thing as 0 plus 3i. That means 0 minus 3i, or just negative 3i, is also a root. So I got to go x minus negative 3i, which would be plus 3i. So there's my third root on that one. Okay, so now let's multiply these together. Let's see, I'm going to multiply these first. I just want to get rid of those i's. So this would be, it's just binomial times a binomial, so just a simple FOIL. So x squared. Outer would be 3xi. Inner would be negative 3xi. So they're going to wipe each other out, so I don't need to put the middle term. The last term would be a negative 9i squared. Remember, I squared is actually plus. So when I multiply those together, I get x squared plus 9, x plus 2, and then keep multiplying this out again. FOIL all that out. I trust that you can do that, so I'm going to put the answer down. X cubed plus 2x squared plus 9x plus 18. Notice they didn't give us any particular information about a certain point, so we didn't have to worry about an a. Okay, so there are a lot of right answers here. Like if I doubled all of these, if I put a 2 here, a 4, an 18, and a 36, that would also be a right answer. It'd be an equation that has these for zeros. But this is the simplest one, so that's one we're going to stick with. Okay, down here now, we're going to, it's kind of more of what we did yesterday in 5a, day 5a. We're going to solve these guys. We're going to factor over the real numbers, solve over the real numbers, solve over the complex numbers, and factor over the complex numbers, and kind of see what we come up with here. So for the first one here, I'm going to see, can I factor over the real numbers? Which basically just can I factor like normal. So x squared minus 25, you might notice that's a difference of 2 squares. So that means it can be factorable. So square root of x squared is x, square root of 25 is 5. I'll go plus and minus. Okay, so that and there it's factored over the real numbers. So no need to worry about factoring over complex numbers because it's everything factored and they're all real. So if I want to solve this, solve over the real numbers, I could go this route and say that -5 and +5, or you could say set it equal to 0, bring this over, so x squared equals 25, and when I square root, I get plus minus 5. And again, I'll just kind of put dashes there. So this guy here now, the next one, so if I just simply factoring it, notice it's not equal to anything, so I'm not solving here. I'll solve it there, but I'm just going to factor it here. There's nothing that factors out. There's nothing both divisible by. And also, if that was a minus, this would be the same situation as that. That'd be the difference of two squares. But this is a sum, and there's no such thing as the sum of two squares. We can't do that. So this one is just not factorable. It's not factorable over the real numbers. Now, could I solve it over the real numbers? Maybe I still could. So I'm going to try to solve that. So I've got 4x squared plus 49 equals 0. Bring the 49 over. 4x squared equals -49. Divide by 4. And when I try to square root here, you'll see can't square root, there's a negative. So I can't solve over the real numbers. But over the complex numbers, come over here, this would be x equals, and it'd be plus minus. The negative there means we got an I involved. Okay, and then see 49 and 4, if I square root both those, it'd be 7 over 2. Actually, I need to put 7 over 2 and then put the I here like that. So there's two complex numbers. They're both imaginary. And the reason why I did that first, because I can't really factor over the complex numbers until I have the solutions. So now that I have the solutions, I could have this as x minus positive 7/2 I, and then x minus negative 7/2 I. And we don't want to write it like this, factor like that. So I'm going to have to, let's say, multiply these together, which I could really, if you want to double, because if I want to get rid of the 2 there, I could multiply, actually 4, I'd have to, so I could multiply this by 2 and that by 2. Let's see here, what might be easiest though? Yeah, that would probably be the easiest, to multiply by 4, because eventually I want it to multiply. If I multiply this out the way I have it written, it doesn't equal this. Okay, so I'm going to have to multiply by 4, and when I do that, when I multiply, I can actually just multiply 2 into this and 2 into that. So think of it as 2 times this and 2 times that instead of the 4. So that'd be 2x minus 7i. And then the 2 going to this one would be 2x plus 7i. And the 2's cancel there with the halves. And now I've got 2 times 2 equals 4. Okay. And if you go ahead and multiply this together, you'll get that guy. Now we want to factor it over complex numbers, so I'm going to leave like this, factored. This guy over here, see if you remember this way or not, it's been a little while, but it's called factor by grouping. So we kind of separate into 2 groups here. So I'll put a line right there. So a little dotted line, if you can see that in the video. A little dotted line. Look at these two. What are they divisible by? Well, they're both divisible by x squared. So I want to say x squared would be x, and then x plus 2 on the inside. And then just kind of ignoring all of that, if I gave you these two, what are they divisible by? They're divisible by a positive 4 with an x plus 2 left over. So I'm adding 2 things together. I'm adding this plus this. Well, what do they share? The 2 things I'm adding together are both being multiplied by x plus 2. I'm going to factor an x plus 2 out. And what's left then would be an x squared plus 4. Okay, so I factor that out. Now, these are, you can't go any further. You can't factor any further with this. If I factor over the real numbers, or if I solve over the real numbers, I can get one of these guys. So this one here, I can get x equals -2, but this one doesn't have a real number solution, so I can't really solve over that real number. So I'm going to leave this as part of my solved answer. If I go over and solve this, guys, then so x squared equals negative 4, because I'm trying to solve this one. Square root, I get x equals plus minus 2, and then an I because I had a negative under the radical. Notice I have 1, 2, 3 answers. The power was to the third. So now if I want to factor over the complex numbers, this was actually, this guy right here factored into x minus positive 2i, and then x minus negative 2i. So there's over the complex numbers, and I can actually throw in the x plus 2, because that is a version of a complex factor. So there would be the factored form there. So if I did over the real numbers, as far as I can go. Now if I factor the complex numbers, I can keep going with this. Okay. Now let's flip this over and get real crazy on the back here. These are some real different ones. When I look at this guy, there's really nothing that I can factor. I mean, there's nothing that comes out of all of them. We don't really have a method for factoring to the fourth power. The only place I can really start, you could try to graph it, and if you graph it, you're not going to see a lot. So I hit graph. You see it just keeps going and spinning, nothing happens, and that's my y-intercept at 100. So this goes up to 10, the y-intercept is off the graph. So maybe I'll try that, I'll try zoom, and then remember the fit, number 0, zoom fit, kind of see what's going on here. My guess is this thing doesn't ever touch the x-axis. Gets down very close, comes back up. I wonder what the lowest side ever gets is. Let's go to, I just want to know what the minimum is here. See if the minimum even gets down into the negatives. Because if the minimum is a positive number, that means this thing's always positive. So it actually never crosses the x-axis, which means it doesn't have any real number solutions. Yeah, so the minimum is 47. It never crosses the x-axis. So this one has no real solutions. So I can't solve. I can't solve over the real solutions. But I know here that I do have, they give me one of the complex solutions right here, 5i. So right off the bat, that can help me. Let's see here, let's try this. So I'm going to do some, maybe you've never seen this before. You can actually do synthetic division with imaginary numbers. So I have a 1, 3, 29, 75, 100. And I'm going to put that 5i over here. Now we do know that if 5i is a complex solution, then negative 5i is also. So I've got two of them now. I've got two of those guys as solutions. But what I'm trying to do is find out what are the other solutions. Okay, so this guy, do exactly the same thing as we've always done, or as we have always done. Drop the 1 down. 1 times 5i is 5i. Remember, we're subtracting down here. So, or I'm sorry, we're adding straight down. We add straight down, so 3 plus 5i. Now if I take 3 plus 5i times 5i, that would be, let's see, I'm actually going to multiply these together for the 5i and the 5i, because that will make a real number, and I want the real numbers first. So if I distribute this, I'm going to distribute to the 5i first. That'd be 25i squared, or negative 25. And then if I take it times 3, that'd be plus 15i. Okay, add straight down. 29 minus 25 would be 4 plus the 15i. Again, multiply these two together first. Multiply the 5i times the 15i, and I would get negative 75. I'll write it up here. And then if I take the 4 times 5i, it'd be 20i. Add straight down. Notice the 75 and the negative 75 are gone. I just got 20i. And then 20i times 5i would be 100i squared, or negative 100. Add straight down and get 0. That's important, because if that wasn't 0, that means they lied to me. They told me 5i was one of the solutions. So when I divide by 5i, I get this. Now let's divide that by negative 5i. If 5i is a solution, negative 5i has to be also. So drop the 1 down, multiply, so 1 times negative 5i is negative 5i. add straight down, this is cool, I got 3. The i's go away. But then when I multiply, I get i's back. So 3 times negative 5i is negative 15i, but look, that's a positive 15i, so the sum is 4. 4 times negative 5i is negative 20i, and that's 0. So perfect. That was a solution. I got 0. Now this, the thing that's left here, this is a quadratic. Remember, it's remainder constant x squared. So I've got x squared plus 3x plus 4. And if you tried to factor that, you'd be wasting your time, because we already know from the graph that it's doesn't have any real solution, so it can't be factored. Nothing multiplied by itself, or no two numbers multiplied equal 4, but then add to give you 3. Can't happen. So this, you'd just be spinning your tires on that one. So I'm going to use a quadratic formula to solve this guy to get, and it's going to be some i's involved because I know they're imaginary, because that graph never crossed the x-axis. So I've got, see, x equals negative b plus or minus the square root b squared is 9 minus 4 times a times c all over 2a. Minus 9, and that'd be minus 16. And so this would be negative 3 plus or minus. That'd be a negative 7, so I'm going to put 7i. And there's the other two solutions. Okay, so 1, 2, and then 3, 4. And that's our 4 we're looking for here. So that's the other two on top of these two. Now, if I was going to write this in factored form with complex, this would be, let's see, x minus positive 5i, x minus negative 5i, and then x minus negative 3, and then 3 plus radical 7i, over 2, and then times, I'll put it down here, so times x minus negative 3, so that's going to be a 3 again. And this one's going to be minus instead of plus. There you go. So there's the factored form over complex numbers. Can't factor it over the real numbers. Couldn't be done. So I just happened to put my work over here. All right, and then the last one, hopefully a little bit faster here. So first off, it says solve for the complex numbers. So here's this guy. That's the only real number I would have gotten, but there's one of them. And it is a complex number, so we can leave it here. I can write my answer for this because I've got x minus 1, and then x, and I'm going to subtract, it'd be x minus 2 minus I radical 3. I got to distribute that negative out, so it'd be minus 2 plus I radical 3. And there's got to be another one, because if this is a solution, that means 2 plus I radical 3 would be 1. So I've got x minus 2 plus I radical 3. If I distribute the negative out, that would be x minus 2 minus I radical 3. My last thing now is, is there a way to write this factored form over the real numbers? So this guy here, this x minus 1 is good. I just want to multiply this by whatever these two multiply together equals. So maybe I'll just multiply this and write the answer over here. So I'm going to take x times x, so that would be an x squared. X times negative 2, negative 2x. X times negative I radical 3, so negative I x radical 3. Take the negative 2 times x, so it's actually going to be minus 2x. Then this would be plus 4, and this would be a positive 2i radical 3. And then I'll take this times everything, so plus xi radical 3 minus 2i radical 3. And then if I multiply these two together, minus I squared 3. So I need to simplify everything in that parentheses. So x minus 1, and here, let's see, so negative ix radical 3, positive ix radical 3, 2i radical 3, negative 2i radical 3, And then this would be a positive 3. So this would be x squared minus 2x is minus 4x, and then plus 4 plus 3 is plus 7. So that would be factored as far as I could. This was going backwards. This is what it looked like factored. And then if I multiply that out, I can find out what the original problem was, but I'm not too concerned about that.